Induction, we check the base cases. Yeah, we check more than necessary, right? Yeah. Yeah. So next we make induction assumption. Assume the formula is true for k between 2 and n. Okay? For certain n. Okay? Yeah. Assume it's true. All right. It's true means if k in this range, we can write fk in that formula. That's assumption, induction assumption. Right. Our goal, we need to verify for Fibonacci number n plus 1. N plus 1. Okay? So if you can derive this formula from your assumption, then we prove it. Okay? Yeah. So that's simple. Yeah. That, yeah. But you need to do some work. Okay? You need to do some work. Yeah. All right, so let's do it. Yeah. Recursion formula, we can use it. Yeah. In that. Think about, because n minus 1 in that range, right? Between 2 and n in this range. n minus 1 also in this range. Okay? That's why we can use the formula for n and n minus 1. Okay? Yeah. Now we want to show this whole expression equals that. Then we're done. Okay? Yeah. These two expressions are the same. If we can show, we complete the proof. Okay? Yeah, that's the induction. That's the induction. Okay. All right. So let's write the second expression in this way. Okay? Yeah, like that. Okay. So we need to compare these two expressions. 1 over root 5, we can ignore, right? We only need to compare these two parentheses. How about that? We only need to prove these two big parentheses inside the same. The expression inside those two pairs, parentheses, the same. That's enough. Okay? Yeah. So let's show it. Let's show these two expressions are the same. Okay? Yeah. All right. Can we split the integral part the same and the fractional part also the same? How can we split? Because structure-wise, integral part should correspond to the integral part. Fractional part should correspond to fractional part. That's based on the structure. Structure. Gene. Yeah. So something you can call, well, because integral, they have similarity. Fractional part, they have similarity, right? So let's split in that way. Our goal, we try to verify these two equalities. Okay? Yeah. The first one, let's look at the first one. Remember, our phi has this property. Can you connect from the phi property? Can you get this? Okay? From that phi property, if we multiply phi to the n minus 1 both sides, what do we get? Multiply this phi to the n minus 1 power both sides, what do we get? Same thing, right? No? Yeah. So we verify it. Okay? This is correct. Multiply this both sides. Left hand side, is it that one? Right hand side, the first term, phi to the n. Second term, phi to the n minus 1. See? Multiply through. Can you see that? Multiply both sides, right?
You're saying take phi squared times phi to the n minus 1.
Yeah, phi squared times phi to the n minus 1. 2 plus n minus 1, is that n plus 1? You add exponents, right?
Correct.
Right. 2 plus n minus 1, is that n plus 1? Yeah. So that's why. Yeah.
What about the right side?
1 plus n minus 1, is that n? 1 plus n minus 1, n. 0, right? 1 times anything. That's the same thing. Yeah. So you verify in this way. So the first equality is verified. Then the second equality must be true. Okay? If the whole statement is correct. Yeah. Now let's verify the second statement. Second equality. Okay. All right. Backward thinking. Right? Backward thinking. In order to make this correct, we go backward. Okay? Let's remove the denominators. Can we remove denominators, both sides, by multiply common denominator? Is this common denominator of all the terms? Common denominator. Okay? Let's multiply it. Multiply the common denominator, phi to the n plus 1th power. Okay? This one we have a phi. Yeah, because after cancellation we still have 1 phi left. Okay? This one, after cancellation, we have phi squared left. Yeah. Common denominator, yeah, after cancellation. All right. But now we need, negative 1 certain power. We need to remove that part. Okay? All right. How about we multiply negative 1 to the n minus 1 power, the same as that. Okay? Yeah. This number multiply that. It's 1, right? Because n plus 1 plus n minus 1, 2n. Negative 1 to the n even number, that's positive 1. Okay? This one also positive, but this one is negative. N here plus n minus 1, it's an odd number, right? 2n minus 1, odd number. Odd number, negative 1 to an odd number, it's negative 1. Okay? You get this. Is this correct? Look at the property. That's correct, right? Remove the 1. Yeah, we used before. We used this 1 equals phi squared minus phi before. Okay? So then, let's go forward, right? Backward thinking, because this is correct. So we can go forward to get that, right? Yeah? Yeah. Because that's the two-way, right? Two-way deductions. Okay. So this is correct. Yeah. So this is correct. That is correct. Yeah. Both correct, right? Both correct. That is correct. Okay. So the whole statement is correct. The whole statement is correct. Okay. Yeah. So that's the math we need to solve the problem. Think about for yourself. Can you handle math like that? No way to handle? No way to handle that? All right. Let me do this. Okay? Yeah. If I do not tell you anything, I ask you to do from the scratch, then it's hard. So I know, so you cannot. How about now I give you a solution, okay? I give you one example doing this. Then I modify a little bit. I ask you to repeat. Use the same method, but you need to change a little bit. Can you handle that? Can you handle that? Yeah, not from scratch, right? So you have an existing example there. Okay? Then you work on a similar one. But you need to do some change. Not exactly the same. Do you feel you can handle that? Okay? Let me show you one example. Yeah. Because I will give you another exercise this week. Okay?